Now it is also possible to use information of one quadratic equation to come up with a totally new quadratic equation that has different roots. So for example, if we are given an equation x squared plus 4x minus 5 equal to 0, and we are told that this equation has roots alpha and beta. Okay, then they're asking us to find an equation that will have roots alpha beta squared and alpha squared beta. Okay, so what will be the equation of this one? So the goal is to first determine the sum and product of the given quadratic equation, and when we do that, we'll use it to be able to find the sum and product of the roots that are given for the quadratic equation that we seek to find. So for this quadratic equation, we can find the sum. We know the formula is minus b over a, so this will be equal to minus of, my b is 4, so I'll have 4 over a is 1, and I'll have minus 4 as the sum of the roots, and the product is c over a. My c is negative 5 over my a is 1, and this will be equal to minus 5. So I'll use this information to find the sum and product of these two new roots of the quadratic equation that we seek to find. So for these two roots now, I need to find the sum. So the sum will be alpha beta squared plus alpha squared beta. So the goal is to express this sum in the form that will have alpha plus beta and alpha beta, so that we can replace the value for the sum and the value for the product. So here I can see that alpha and beta are common in both, so I can say, okay, alpha and beta are common, close brackets. So for the first term, alpha is gone, then one beta is remaining, plus here one alpha is remaining, the beta is already out. If you multiply this, you're going to have alpha beta squared plus alpha squared beta, which is the same as alpha beta, open brackets, alpha plus beta, since addition is commutative. So at this stage, we can find now the sum of these two new roots, since we've expressed it in the form that has alpha plus beta and alpha beta. So this will be equal to the product here, alpha beta, we have minus 5, and it is being multiplied with alpha plus beta, which is the sum, and that's minus 4, and this will give us 20, which is a positive. Okay, and if we now try to find the product, so the product will be alpha beta squared, and this is being multiplied with alpha squared beta. So like terms will multiply each other, so alpha times alpha squared, this will be alpha raised to 3, beta squared times beta, it will also be beta to the third power, and this I can say it's alpha beta everything to the power 3. So this will be equal to, I just need to plug in the value of alpha beta, So from the previous work, we know the value of alpha beta is -5, and we are cubing this value. So since my power is odd, I know the negative will come back, and 5 raised to 3, it's 125. So now I have the sum and product of the roots of my new equation. So I just have to go to the standard form, which is x squared minus sum, which is alpha plus beta, okay, x plus alpha beta equal to 0. This is the standard form. Okay, so in our case, we have our own sum, we have our own product. So just say this is x squared minus the given sum that we have plus the product that we have, and it will be equal to 0. So we have the sum as 20. As we can see, the sum is 20 up here. So we have x squared minus 20 x plus the product. Now plus times minus, it will be minus the product, which is 125, and it will be equal to 0. So this is the equation whose roots are alpha beta squared and alpha squared beta. So the same thing, we can prove that if we find the sum of this equation, we know it's minus b over a. We're going to arrive at the sum that we found earlier. So we have minus of b, our b here is -20, over a, which is 1, and we'll have 20. So this is our sum, which is the same as the sum we found earlier. Our product, we know by formula it's c over a. Our c is minus 125 over my a is 1, and this will be minus 125, which is the same value we found for the product.